Okay, today we want to have a look at not the derivative of exponential functions like we did in the last video. We want the derivative of logarithmic functions. Once again, it's just a series of rules that you've got to learn. Now, the general rule is we're going to look at the graph, the differential of y equals the natural log of x. First of all, last video I introduced the concept of this transcendental number e to you. So if I took the log of x base 2, clearly we understand what that means. If I took the log of x base 2.71828, etc., whatever it is. So in shorthand fashion, the log of x base e, as we can do powers of base 2.71828, we can also do logs base 2.71828, logs base e. We write that down as this, natural log of x. That's an L and an N. It's not an IN, it's an LN. Logs, natural logs. So natural logs, so whenever you see LNX, you're doing logs base e, and you'll find the natural log button on your calculator. Now, just like derivatives of exponentials base e have a certain rule, so too the logs base e have a certain rule when you do differential as well. So when we do the differential of the natural log of x, it simply comes down to 1 on x. Now let me just give you an example of that that's worth noting. So for example, if I had y was equal to, say, the natural log of 6x, and I want to find the differential of that. This is another example of a chain rule. The outside function is you're taking the natural log of something, and that something on the inside happens to be a function itself. So as a chain rule, it's the natural log of u, where u is equal to 6x. If we now go and do a fully worked chain rule, the differential of y in terms of u, well, log of x gives derivative to be 1 on x, so log of u will be derivative of 1 on u. Differential of u in terms of x is going to be 6. Now, continuing this on up here, our fully worked chain rule, our differential of our original function is differential of the outside multiplied by the differential of the inside. So differential of the outside is going to be 1 on u, differential of the inside is going to be 6. So it's 6 over u's value, 6 over 6x, which, the 6's cancel out, I'm left with 1 on x. That's very interesting. The natural log of 1 lot of x derives to 1 on x. The natural log of 6x derives also to 1 on x. So it seems that we actually modify this formula a little bit. So the natural log of any particular constant times by x is just going to be 1 on x. That's an important point to note. So we'll rub this off, and then I'm going to give you one more example to look at. Okay, let's have a look at this scenario here. Y is the natural log of x squared. So clearly I've set it up as a chain rule. So y equals the natural log of u, u is equal to x squared. So the derivative of this is going to be 1 on u, derivative of that is going to be 2x. So I'm just going to speed the process up because we understand chain rule very well. So the original function, its derivative is going to be the differential of the outside, 1 on u, multiplied by differential of the inside, which is 2x. So that's 2x over, I'll take u out, replace it with its value, x squared. That 1x on the bottom cancels one of the x's. The x on the top cancels one of the x's on the bottom to leave 2 over x as the derivative. Please note the difference. If there's some particular constant multiplying in front, it doesn't make any difference, it still derives to 1 on x. If it's a power up here, well, it seems like there's a shortcut that we can apply as well. Let's see if you can look at this initial scenario and see if you can jump to the answer in one step only. If you can learn how to do it by inspection, that's going to make your life very quick and easy on a lot of the problems that are coming up. So good luck on derivatives of logarithmic functions.